Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet and we were doing binary search. In that we were following the lower or upper bound pattern in binary search. So today we will solve another question called find kth rotation. So let's read the problem statement. We will be given an integer array called nums and we have to rotate the array to the right by k times, k steps, where k is a non-negative integer. So k will be always positive. Here you can see in the constraint also, k can be 0 also, or k can go till 10 power 5. And what is 10 power 5? The num's length can also go till 10 power 5. Okay. Now here we have to return the nums array, but after k times rotation towards the right side, or you can say clockwise direction. Okay. So let's see the array here. This is the original array, and if we will rotate this for one time, so definitely the one which is present at the 0 index, na? Yes. So it will come at 1 index, correct? 3, 4, 5, 6, yes. Now 2 which is present at 1 index, it will come at 2nd index, and so on, and everything will be shifted towards one time, and the 7 which is at the last, this will come at the beginning, correct? So 7 will come here at the 0 index, and that array is called nothing but one time rotation towards the right side or clockwise direction. But the question asks us to return the array after k times rotation, means after one time it looks like this. Correct? So how can we rotate this for one time? Because if we can rotate one time now, definitely we can run the same code for k times and we can get the final answer. Yes, but how to rotate for one time? Let's see. So here whatever is there at 0 index, I want this to go at 1 index, correct? Similarly, whatever is at 1 index, I want to move it to 2 index. So can I say every ith index, I want to shift at I plus 1? Yes or no? Yes. Can I say this? But do you think we should move towards left and right? Like towards left to right? Why I am saying this? Because if you remove this 1 from here and you'll copy it here, then how will you get to know ki what was the previous value? In this case, you have to make a previous pointer, correct? Yes, so we can do that way also, ki move to the next pointer but save this in temp variable. Again move to the next pointer but save this in temp variable, and move the previous temp to here, and so on. But it will be little bit confusing. Why not to do from the right side, right end? Because we know na ki this only 7 we want, so that we will save in the temporary variable. And now this 6 we can keep it here. Now this 5 we can keep it at 6, because now we don't need to worry about what was the 6, because this 6 we have already shifted to the next position now. Yes, so I want to run the for loop from int I is equal to what? N minus 2 times. Yes, why I am saying this? Because I want to fit this 6 here na. This 7th I have already taken care or stored in a variable. So let's say temp variable, we have stored nums of what? N minus 1. Now I want to do this movement from which element? N minus 2th element na. So that is why we have initialized, and we want this I to go till greater than equal to 0 and I minus minus. Okay, so initially I is at here, this location, n minus 2. So this location, what I want to do? I want to copy this element and put at I plus 1, yes or no? Yes. So what I am saying, at nums of I plus 1, I want to put nums of I, correct? Yes. So now this 6 will be overwritten, like this 7 will be overwritten with 6, correct? Can I say this? Yes. So let's remove this and put here 6. Okay. Now next time my I will point to here. So now this 5 I want to copy it here. So again I plus 1. At I plus 1 we will put I. So I is at 5th index, like 4th index. So that 5 value will be copied at 5th index, which is 6. So hence I can say this 6 will be overwritten by 5. Next time the I will move to here. This 4 will be copied to this 5. So now this 5 will become 4. Now I will move to 2nd index. Now I want to copy this 3 at 4, correct? So now this 4 will be overwritten with 3. Similarly, now next time the I will point to 1st index and I want to copy this 2 at 3rd position. So now we can overwrite this 2. Now at last I will point to 0 and this 1 I want to copy here, correct? Yes, so this will be copied. Now can I say ki from first index to last index everything has been shifted by one time, and now what I want to put at 0th index, if you remember the 7 which you have removed and that we have saved in temp variable. So after coming out of this for loop we can simply write na ki nums of 0 index I want to save this temporary variable, correct? Yes. So means if you will run this code now, everything will be shifted towards right by one time. Can I say? Now if I want to run this or shift this for k times, can I put this whole in another for loop where I want to run that j index from 0 to j what? K times? Yes, definitely, because if we run one time we can see that this whole for loop has shifted for one time, this whole array. Now if we will run for second time, again it will get shifted towards right side. So next time what will happen, this 6 we will store somewhere, 5 will be moved, 4 will be moved, 3 will be moved, 2 will be moved, 1 will be moved, and 7 will also move. So now this array will look like 7, 1, 2, 3, 4, 5, and the 6 which we have removed we'll put it here. So now it is 6, 7, 1, 2, 3, 4, 5. Similarly one more time, now 5 we will save and this 4 will be shifted here, 3, 2, 1, 7, 6, and that 5 which we have removed we'll put at the beginning. So now it will become 5, 6, 7, 1, 2, 3, 4. Yes, so we can run this entire code in another for loop, nested for loop, which will run for k times. Okay, so here is the code. We will first calculate the nums.length, and we want to run this outer loop for k times because that decides how many number of rotation we want, and the inner code like code till here will actually do the rotation by one time. Okay, so what we do for the rotation, first we save the last element value nums of n minus 1 value in temporary variable, and now we'll run this loop from n minus 2 to where? Till 0. And what we want to do, whatever is my jth value, I want to put at j plus 1th value, means towards right side, correct? And once we have shifted everything, at the 0th index I want to save what was my last value which I have stored in a temp variable, correct? After running this for k times, we can say ki yes, the whole array has been rotated by k times. Okay, so now we can run this, and as you can see it has been passed, so now we can submit this also. But you will see you will get TLE. The reason is, let me show you. See, here is our TLE, correct? So why we have got the TLE? Because, so if you see the time complexity here, O of k times because of the outer for loop, and O of n times because of the inner for loop. So it will be total k into n. And if you see here the constraint, k says k can also go till 10 power 5 and n can also, nums.length can also go till 10 power 5. So n into k will become 10 power 10, and you know beyond 10 power 8 it might give us TLE or it will be very slow, correct? And because it is giving us TLE, so definitely we have to optimize it. But how can we optimize? When the array is sorted, we can apply the two-pointer concept, if you remember, which we have discussed in the very first video of our playlist, how to identify which pattern to apply when we have to optimize it. And because it is sorted, so we can think of two-pointer approach, correct? Yes. But here we can think of binary search. Why? Because after k times rotation na, it is, you can say, ki sorted in two parts. Half part, left part and right part, correct? So hence we categorize in binary search problem, but when we want to optimize it, we can apply the two-pointer concept and we can solve this question in O of n time complexity. But how? Let's see. So original array was 1, 2, 3, 4, 5, 6 and 7, correct? Okay. Now what is the output we want? We want the output to look like 5, 6, 7 and then 1, 2, 3, 4, correct? This is what we want. Okay, let's move it here. So if you see, 1 was at 0 index, correct? Yes, 1 was at 0 index, and now after rotation 1 has come to which index? If you see, at 3rd index. Yes, 2 was at 1st index and now it is at 4. 3 was at 2 index, now it is at 5. So if you see the difference, 5 minus 2, 4 minus 1, then 3 minus 0, the difference is 3 only. And what is this 3? That is nothing but k. Yes. So can I say ki every element we can directly shift at I plus k na? If I is at index, we can directly shift at I plus k. See, so what I am saying, suppose if my I is at this index, I is equal to 0. So I can put here at I plus k. Yes. Similarly, if next time my I will move to this index, then like second index, like for 2 element, first index, then here it will also come at I plus k, means 1 plus 3 means fourth index. Yes or no? Yes. I can do that. But what is the problem there? If we will apply that concept, what type of problem can be arise? The problem is, if you will directly pick this element na 1 and keep it at here I plus k, correct? So after overwritten, the 4 will miss. Where will you store that 4? Because you cannot override without keeping 4. Otherwise, how you will get to know ki where you should keep the 4? Definitely you should store in some variable, correct? Yes. So that 4 we will store in some temp variable, let's suppose. Now what is our next task? Should we keep this 2 at next position, or should we keep this 4 now? Definitely we should keep this 4 now. Otherwise again you have to store this 5 in some variable, next time this 6 in some variable, next time this 7 in some variable, correct? And that will be very tough. Yes. So hence you can do this ki after putting this 1 at this location, store the 4 in the temp variable, and now focus on putting this 4 at its correct location. So what will be the correct location for this 4? That will be nothing but original location of this 4 plus k. Yes or no? Yes. So original location of 4 is 0, 1, 2, 3, correct? And plus k will be 6. So hence it will come here, correct? So can I put this 4? Yes. Now in the temp variable, what will be the value? 7. So now temp variable will have 7. Now we have to put this 7 at its correct location. So what is the current location for this 7? That is nothing but 6. What will be the next location? Plus 3, but 9 will go out of index na. So hence you have to take the modulo operator. Yes or no? Yes. With what? N length. Now 9 modulo 7 and you will get 2, and if you will find ki yes ki 2 0 1 2 is the correct location for 7, correct? So here you will come and you will update with 7. Now what was the previous value? 3. So in the temp variable now you will put 3, and now you will try to find the correct location for 3. How you will find the current location of 3, which is 2, plus 3, which is 5. So you will go with 5th index. Here you will update with 3. Now in the temp variable you will store 6, and so on. So this is the another method, far optimized way compared to the previous one, because here you are going at every location and trying to put the value at their correct position. So first you put 1, then what was the value here? 4. So next time you will try to fit this 4 in the correct location. What was the previous value? 7. So next time you will try to fit the 7 in their correct location. What was the value at that time? 3. So now you will try to fix the 3 at the correct location. What was the value at there? 6. So now you will try to fit this 6 at their correct location, and so on. So this is one of the technique, and the more easiest way will be this. The whole problem of overwritten only occurred na, because you were modifying the same array. What if you will make a temporary array copy of this original array? Okay. Yes, and now what I want to do now, I want to override this in the temporary array. Okay, and if I want the original value what was here, so that we can read from the original array. Yes. So basically run the whole for loop for this much times. Okay, and what is the value? What is this value? ith index value. So this ith index value you have to keep at I plus k modulo n. Yes. So you will keep here. Okay. Now the 2 you will keep here. Now 3 you will keep here. Now 4 you will keep here. Now 5 you will go 5th, like the index for this is nothing but 0, 1, 2, 3, 4. So 4 plus k, 3, total 7, modulo 7, it will give you 0. So this 4 should be kept at 0, this 5 should be kept at 0 location. So you will put 5 here, now 6 here, now 7 here. So in just O of n you can solve this problem, and here you don't need to take any extra variable of temp and keep on moving in the same array. Okay. So what will be the time complexity? O of n, but here the space complexity will also be O of n. Why? Because you have created a temporary array for yourself now, so that you don't need to modify the original array. Yes, so hence the time complexity along with the space complexity will be O of n here. Okay, so now let's code for this. Int n, we will calculate the length nums dot length here. Yes, now what I want to get the original k, because the k might go beyond the length. Now suppose the length is 5 and k is 7, so that we don't need to repeat this or rotate this for 7 times. Now see here, if the length is 7, okay, and the k is 9 suppose, so do you think after 7 rotation, this 1 will again come back to the same position? Na? Yes. So for 8th rotation again 7, 1, 2, 3, 4, 5, 6. Now for 9th rotation 6, 7, 1, 2, 3, 4, 5. Correct? So instead of rotating it for 9 times, you know na ki the length is 7, and after every 7th multiple rotation the array will become original array. So hence how many times leftover we have to return or rotate? That is nothing but n k modulo 7 or n. So you will get here 9 modulo 7, 2. So originally you should have rotated this only for 2 times instead of 9 times. That will save our extra time complexity here. So hence we will do ki k is equal to k modulo n, because we want the original k to be iterated. Now what we want to do, we want to make a temporary array, correct? So temp is equal to new int of size n, correct? Yes. Now what I want to do, I want to run for this I is equal to 0 for how many times? I want to run for n times, correct? I plus plus. Okay. Now what I want to do, for every I want to find the original index, correct? So the new index will be what? I plus k. Yes, I plus k, but modulo n, because we have to write in a cycle rotation, correct, format. Now at this index, what we have to do? In the temp, add this new index, correct? Yes, we have to write the value for what? Nums of ith value. Yes. Now after that many times, like after n times rotation, we can get our final answer. So all the answer is saved in where? In the temporary array, na? But here the question is not asking the new array which we have changed. No, it is asking to modify that. Okay, so now whatever is in the temp array, we can directly copy in the nums array, and then we can keep it as it is, so that nums array it can read for the answer. So we again have to run this for loop for int I is equal to 0, I less than nums dot length, correct, and then I plus plus. What we want to do here, in the nums of I, we want to put the value of temp of I, whatever it is, means just copy paste in the nums of I, and we can run this because the question is not asking to return anything, so we'll simply run this code. So now we have submitted, and the time complexity will be O of 2n, correct, and space complexity will be O of n. Can we optimize it more further? Means what if the interviewer asks you why you are using extra space complexity when the question is only asking to modify the whole array, correct? It is not expecting you to return the array. So we can do that by modifying it also. But how? Let's see. So that thing which we are talking about now is nothing but the observation here, and what we observed from the original array 4, 5, 6, 7, okay, and k is equal to 3. I will definitely recommend you all ki when you are interview na, talk about the brute force code and talk about the code which we have just discussed. This is the more optimized form, but this you cannot come if you don't know about the previous things. So don't directly jump onto this one without even discussing in the interview. That is very important. Okay, we have to return our answer like 5, 6, 7, 1, 2, 3. Okay, so what we saw now, this 1, 2, 3, 4 has been shifted here, and this 5, 6, 7 is here. Okay, so what we saw ki if you will rotate the entire array na, so the entire array will become 7, 6, 5, 4, 3, 2, 1, correct? And if you will see, don't you think ki this part and this part is nothing but again rotation, and this part and this part is nothing but again rotation? So yes, after fully rotation you can rotate in this half and then rotate in this half, and then it will become the original array. So here you can see in Java ki first we have to reverse from 0 to total length, and then from 0 to k minus 1, and then again from k to last, and hence you will get your final original answer. In this condition the total time complexity still be O of 2n. Why? Because first time you are reversing the whole array, so O of n. Second time from O like 0 to k, so k, and from for third time k to n, correct? So total these two together will take O of n, and the original will O of n. n. So time complexity is O of 2n, but space complexity is far better. So here is your Java solution for this, here is your Python solution for the last one, and here is your C++ solution for this. Now if you want the previous one which we have discussed, the far optimized way, so this was your Java solution, here is your Python solution. If here I am rotating it but by taking extra space complexity, and here is your C++ solution. So with this we can go in our sheet and we can mark the second question as to be done. I hope you guys are doing along with me. If yes, do let me know in the comment section, and if you have any doubt, do let me know, and you can share with your friends also if you feel these videos are helpful for you. That's it. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.